Right, so here we are, question 7, 2019 paper, and we asked to sketch two graphs. 3 to the x plus 1, or more correctly, f of x equals 3 to the x plus 1, and g of x equals 3 to the 2x. Okay, so both of these are clearly exponentials because, hey, we got x in the exponent, right? So for the first one, f of x equals 3 to the x plus 1. Hopefully you've got the starting point, which is we've got 3 to the power of x plus 1. The base is a number that is greater than 1. So we have our shape that looks like it's increasing because we have a positive x value up top here. Now, one way to always just check yourself is plug some values in and check. So when x is 0, we've got 3 to the 1. When x is 1, we've got 3 to the 1 plus 1, which is 3 squared. When x is 2, we have 3 to the 2 plus 1, 3 cubed. So the idea here is that as we're putting in bigger values of x, we're definitely getting bigger values of y. So the graph must be increasing. We have a sense of its shape already. Okay, now you're going to go about this in a few ways, and each person tackles it slightly differently. You might see, oh, well, this is x plus 1, and we already know, say, from like if we were to draw a parabola that said y equals x plus 1 squared, well, we know that that parabola, based on our original parabola of y equals x squared, well, this graph has moved, right? It's translated. The turning point is now at minus 1, 0. In other words, the graph has moved to the left by 1 from this graph here, or just from its turning point, you can see it. Okay, so that thinking still holds true for this graph, where if we think of what the graph of y equals 3 to the x looks like, this graph is the same, but it's just moved to the left by 1. X plus 1, it's moved to the left by 1. You'd have to put minus 1 to have. Okay, so the other way that we can also look at it is the way I was talking about before, which is plug some values in and see what's happening. So if we put 0 in, then for f of x, f of 0 is 3 to the 0 plus 1. Well, that's just 3 to the 1, which is 3. In other words, when x is 0, y is 3. Okay, so we've got 1, 2, 3. There's a point that lies on f of x. We already know it's increasing, so we know it has some sort of shape like that. But now another question is the asymptote. There must be a horizontal asymptote because it's an exponential function. Now, the graph of y equals 3 to the x. I'm starting there because it's a nice starting point to go, well, I know what y equals 3 to the x looks like. It increases and it has an asymptote at, well, hopefully you're going along, yes, no, I know this, or, oh, what's he going to say? I don't know, but we've got y equals 0. It never crosses the x-axis because 3 to the power of anything is going to be a positive value, right? 3 to the x, 3 to the 1, 3 to the minus 5,043, 3 to the anything is going to be a positive value. So therefore we know that this has an asymptote on this axis over here. On the x-axis, y equals 0 will be an asymptote. Okay, so now you can draw your graph. Now I'm just going to draw it roughly to start with, but because we've got a grid, which is vaguely annoying in some ways, we need to be a little bit more accurate because this point here is obviously on the graph 0, 3, but what happens if we put 1 into our graph? Well, I'm going to replace x with 1, and 1 plus 1 is 2, 3 to the 2 is 9. In other words, 1, 9 is on the graph. We expect this because we're multiplying by 3 every time. So actually now 1 and 9 is important, which just shows how bad my shape was to start with. And we could also maybe put in f of negative 1, which is 3 to the negative 1 plus 1, which is 3 to the 0. And of course, anything to the power of 0 is 1. So negative 1, 0. What am I saying here? Negative 1, 0. Anything to the power of 0 is 1. That's fine. I'll leave in these, right? Because these are the things that we're like, wait, what? But notice how I caught myself. Why? Because I know there's an asymptote at y equals 0, so it doesn't make any sense. How can I reach the asymptote? Kind of definition of an asymptote. Okay, so at negative 1, we're actually sitting at 1 they're going to be now the integer values, y values. It hits to the left here. So now we can draw our graph a little bit better. It goes through these values and increases, and it approaches the asymptote as you get to further negative values. Now watch out, I haven't drawn that really well, but easier to draw on a paper. Make sure that you do approach the asymptote and you don't approach and then turn away, because conceptually that's incorrect. Okay, well, that was f of x. I don't know what else we need to do. Show any asymptotes, intercepts with the axes, and points of intersection clearly. Okay, so the point of intersection is going to be the interesting one. So for our other graph here, g of x, we've got 3 to the 2x. Okay, from the same logic as here, we know that this graph is increasing. Now I'm going to just play a little bit of algebra trickery to start with here to go, well, 3 to the 2x is 3 squared to the x. In other words, that's 9 to the x. Now the reason I wanted to look at it like that is, well, that's easy because I know this is definitely a nice increasing graph. I know that it goes through 0, 1, because I know it's kind of one of those basic exponential graphs. I know the asymptote is at y equals 0 as well. The graph has not moved up or down. It hasn't really moved left or right. And I'm not going to go into how this domain feels like it's, well, the domain is the same. So we're not going down another path, possible path there. So let's just plug in some values to see where we're at. Well, I already said g of 0. Well, that's easy because that's 3 to the 0 or 9 to the 0, however you want to look at it, which is 1. In other words, 0, 1. G of 1, well, that's going to be 3 squared or 9 to the 1, whichever version you're looking at. I'm going to stick with the 3 here because I presume that's how you would have done it. So 3 to the 2 times 1, which is 9, which means that it goes through 1, 9. Oh, have a look at that. 1, 9, 1, 9. That's where they must intersect. So we know that it goes through there, and I'm going to put a cross here so we can differentiate these. We know that it goes through there as well. We know that it's increasing, so we know that it's going to do this. Well, I'm just trying to get this. It must be increasing quicker than the other one, right? And so it's going to go down there somewhere. That last part, I'm really not doing well with my drawing here, am I? And it's decreasing a whole lot quicker than the other one, right? Okay, so that seems like a goodie, right? Clearly indicate all these other lovely things. Well, 0, 1, 1, 9. I'm even going to write here, point of intersection in this lovely handwriting. Okay, that was fairly long-winded in some ways, with a lot of things going on, because there is access to think about these in so many ways. Okay, so hopefully that was vaguely helpful. I'm just going through part A of drawing and the points of intersection and see if that does us. Now, the only thing that I'm left thinking about is points of intersection, but I only see one point of intersection because this graph is increasing at a quicker rate. So I'm not sure why it says indicate intercepts with the axes. Oh, I guess it's just like show intercepts with the axes, and there was only one, and there was only one point of intersection. So points. Okay, well, hopefully vaguely helpful. You know, comments below. No, I'm kidding. I just like thinking of that, you know, like and subscribe and all of those. Anyway, hopefully helpful. Cheers.